Now, this video is meant for sort of pre-calc students who've already seen complex numbers before, so it's going to be a quick review of a few things that we can do with complex numbers. One of the big things we want to remember is, where do complex numbers come from? So right off the bat, we want to think, well, typically when we solve a quadratic equation, we expect to get real numbers. So one way to solve a quadratic, such as the one given here on the screen, is using the quadratic formula. So I've set that up here for you. Remember, negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I went ahead and simplified a little bit, again, getting rid of those extra negatives, multiplying on the bottom. And the most important part, simplifying the discriminant, right, inside the root down to a negative 1296. What that means is the square root of a negative number would not be a real number. So remember, what we can do is split that up into a negative 1 multiplied by the square root of 1296. And the square root of 1296 very nicely is 36. So we can say 6 plus or minus, again, it'll be a 36. That allows us to take that square root, only now we need to remember that we need to include that imaginary I, right? I being equal to the square root of negative 1. Again, that's all going to be over 18. And now it allows us to at least come up with what we call, again, a complex answer. It's not going to be a real answer, but a complex answer. 6 divided by 18 being 1/3, plus or minus 36 over 18 is 2i. 1/3 plus 2i, and 1/3 minus 2i being two complex answers. Now, this video is not so much about solving equations to find complex numbers as it is about simplifying and working with complex numbers. So some of the basic things that we can do would be adding and subtracting, or even distributing, such as the example in the upper left. If I distribute that 2, right, to both parts, we just treat I kind of like a variable. So again, that's going to be 6 plus 10i. I also need to remember to distribute this negative, so minus 4 plus I. And basically, we're going to get 6 minus 4 being the real part, and 10i plus 1i being the imaginary part of our answer. But we'll sort of have a two-term answer in, again, what we call the standard form of a complex number. A being the real part, and b being the imaginary part, or bi being the imaginary part of our standard number. Over at the right, again, we just follow the order of operations, basic simplification. Remember to pull those i's out, pull those negative ones out, call them I, right off the bat. So we want to call this I root 4 times I root 16. But again, that's going to be a 2i times a 4i, which basically becomes 8i squared. And remember, if I is the square root of negative 1, then I squared is just that square root squared, or basically it's going to be a simple negative 1, which means this is 8 times negative 1, right? That I squared, which just becomes negative 8. I squared basically just changes the sign of the number, but now it's actually a real number. I squared is actually still real. So if we do that same idea, when we're foiling out, or we're distributing this 3 plus 2i squared down here, down at the bottom, 3 times 3 is going to be 9. On the inside, we would get a 6i. And on the outside, right, 3 times 2i distributed twice here. So we're going to get that same thing twice. And then we would add on 2i times 2i being 4i squared. Well, remember, we just said I squared makes that negative. So basically, we have 9. It's going to be a minus 4. And in the middle, again, that's just simply 12i, or a final answer of 5 plus 12i, right? That standard form number. Finally, if we're dividing, again, the main idea is to get this I out of the denominator. We don't like roots, right? Square root of negative 1. We don't like roots in the denominator. So what we need to do is multiply by what's called the conjugate. Some might say, hey, we'll just multiply by I. I squared is real, correct? But again, if we multiply both top and bottom by I, we're going to have to distribute it on the bottom, and we're going to end up with an imaginary part, right? That'll just be 4i. If we try to multiply by itself, like let's say we tried to multiply 4 minus 2i by 4 minus 2i, well, remember what just happened to us over here at the left. When we squared an imaginary number, we still ended up, right, with that 12i down here, we still ended up imaginary. So that didn't cancel the i's out of there. We still end up with that middle term. But if we use what's called, again, the conjugate of an imaginary number, 4 minus 2i means I'm going to multiply by 4 plus 2i. Again, both top and bottom, as long as we do the same thing on the top and bottom, right? That's legal algebra. What's going to happen is we'll be able to cancel away that number. So let's go ahead and watch what happens here. 4 times 4, I'm going to go ahead and distribute on the bottom here. 4 times 4 is 16. That leading 4 times positive 2i would be a plus 8i. Inside here, negative 2i times 4 is going to be a minus 8i. And finally, we've got negative 2 times 2 makes that a negative 4i squared, which again is going to change the sign. That's basically plus 4. So what we're going to end up with is really 16 plus 4 in the denominator. But the nice thing is that 8i and that negative 8i would just cancel away. So we just found a way to get a real number in the denominator, right, down here. We really just have 20 right now. And we'll simplify that more here just a little bit more in a minute. We still need to finish up the top though, so I'm going to very quickly just FOIL that out. Again, you get a 4i and a 12i, and we're also going to have a plus 6i squared. Again, that makes for 8 minus 6, and we've got 16i over there. So basically 2 plus 16i over here. And because everything's even, we could go ahead and divide. And in fact, let's go ahead and split it up into real and imaginary. 2 over 20 would be a 1/10. And we're going to say plus 16 over 20 would be 4/5 I. And that would be our, again, standard form complex number. So those are the main ideas of what we can do with complex numbers. I'm going to make this video a little bit longer, just talking a little bit about that powers of I. So if you want to bear with it, feel free to keep on watching. Otherwise, good luck with your homework. Again, I'm going to talk a little bit, though, about the powers of I. Remember that I, being I squared, canceled down nicely to -1. So you'll see that over here, right, on the left side of our complex plane. The complex plane being a real axis, left and right, an imaginary axis up and down. Well, remember, if we sort of count our way around our i's, I to the first power would be directly up 1 unit. I squared would be directly left 1 unit, because that's really -1. Then we've got I cubed, basically I squared times I, right? So this would be I squared times another I, which is just a -1 times I. Makes sense that we would get negative I there, right? It kind of works our way around the circle then, right, as far as we're going. If we do that one more time, again, I to the 4th is basically just going to be I squared times I squared, or -1 times -1 is a positive 1. And if we multiply by another I, again, we just make our way up and around here. Again, we just get I back again, because it'd be I times I to the 4th is I times 1. That's really just I. So again, it just cycles around. So let's talk about this at the left. If I wanted to find I to the 15th, if I take 15 divided by 4, right, it's a cycle of four spots, 4 steps. I get 3.75. I'm not that worried about the 3. That's just 3 full cycles, right? That's 3 sets of I to the 4th. So it'd be I to the 4th 3 full times, right? And then multiplied by, again, just I to another 3/4 of a cycle, right? That's what that 0.75 is telling us. That's 3/4 of another cycle. So that's basically an I to the 3rd out here. Right? Well, I to the 4th to the 3rd really is just 1. So we can get rid of that, because that's really just 1 times. And I to the 3rd, we already know down here at the bottom, is -I. So that's why we can say that I to the 15th is really -1. -1i, sorry. Let's try I to the 89th. If we have a really big power, 89 divided by 4, it's going to be about 22.25, right? 1/4. Again, I'm not that worried about the full cycle of 22 there, 22 times around the circle. What I really care about is that that's an extra 1/4. So really, I to the 89th is the same thing as I to the 1st, because that's 1/4 of a cycle, right? It would be that top of the circle, 1/4 of a cycle away around. And I to the 89th is really just the same thing as I. So the nice part is you never have to have I to a greater power than just the first power. So let's take a look at a couple of big problems. I'm going to go kind of quickly here. On the left, if we distributed, right, if we kind of made those things distribute out here, we could get this nice long expansion, and then we subtract some like terms. And now notice what's going to happen here after I distributed that negative 1. 1 minus 1 is actually going to disappear. So we've got this first term and this last term, they're gone. Negative 4i and negative 4i, they're going to combine. And those 4i squareds, remember, just become positive 4 and negative 4. Basically, they add together and they cancel away as well, right? They become negative and positive 4, which basically disappears, and we just get negative 8i, I to the first power. So all those powers of I, again, they sort of disappear. They either become imaginary or they become real, but they don't become anything more than an I to the first. If we did the same thing over here at the right, we've got an I to the 15th, so we'll deal with that in a minute. We've also got a negative inside the root. So the first thing I would do is pull out that I times root 2 to the 6th, which again is just I to the 6th times root 2 to the 6th. Then let's talk about the details here. I to the 4th, right, is going to be 1. I to the 6th, right, therefore is negative 1 times negative 1 is going to be a negative 1. I to the 15th, again, kind of breaking that down, is just going to be a negative 1 I, right? So I to the 6th here is now negative 1. Square root of 2, right? Again, if we think about roots, they're a fractional exponent. Or if you really think about it, that's really the square root of 2 times the square root of 2, or the square root of 2 squared, right, to the third. So basically just 2 to the third. And what's going to happen is 2 to the third becomes 8. Again, that I to the 6th in the front became negative 1, so that's negative 8. And I to the 15th on the tail end here just became a negative 1 down at the bottom. I know I went through that fairly quickly, but again, feel free to pause the video, read through the details. I think you'll see everything makes sense. Otherwise, make sure you talk to your teacher, and have a great day.